Chapter 5 is water supply systems, and this chapter is really something a little more intense than people realize. We're not going to talk about where the water comes from for your fire hydrants and stuff, but how basically things are distributed all together. If you look at where we're at, the objectives of pressures and flows and movement of water are all key to this chapter, and identifies the water supply and the network system that's involved in the water supply. So instead of us just filling out questions and things like that at the end of the chapter, you need to understand the difference between a municipal and a public water system and a private water system. They're all key to what happens here. So the big thing is when we look at this, um, we're constantly looking at how things are going to come into play in regards to how we get our water. Sometimes they're pumped, sometimes it's a gravity system. How we deal with friction loss and how it affects the water supply. What's the thermostatic pressure and residual pressure? These are all key things that you got to look at. And the big thing is that we got to look at what NFPA is talking about. Define what the term churn means, the rate of performance, peak performance, and what a stationary fire pump testing is all about as well. So when we start looking at this chapter and we start getting into some things, one of the big things I'm looking at for you in the introduction is water is a necessary item. We use it every day of the week, 365 days a year. Engineers are fire protection engineers and water distribution engineers basically determine the quantity and source of water that is needed to provide water to basically an urban area, suburban area, rural area, or in fact to a major city. What fire flows are needed and how they're going to manage those systems. Determine the adequacy of the water supply is real important. And what are the critical factors in designing a water-based fire protection system? All this comes into play. And the first thing we start looking at is the water system supply system. Most of the time you'll see transmissions, distribution, laterals, network that's put together, water from multiple sources. It can be from a well, from a aquafill, could be from anything. And the big thing is water is necessary. Got to remember the fire mains that we have out there is the same as what we drink as a domestic water system. So the FL is a fire lane and the FM is a fire, FL is for fire line, excuse me, and FM is for fire main. NFPA 24 kind of dictates how all that gets put in. And if you notice in this particular picture, behind the fire hydrant is it looks like a hunk of concrete that's just laying there. That's called a thrush block. That's in there for design because that's a pressure fit against the fire hydrant and holds it in place. So when we're looking at fire mains and fire systems and water systems, one of the key things is the valves, how we shut this thing down. And you'll see it in this slide real quick where they got a T-handle wrench into a valve pit that shuts the water off to the hydrant. Not to anything else, but to the hydrant. So when you start looking at fire hydrants, you start looking at where they're at, how they're located. Basically, in this case, it's on a street corner. The valve pit could be to the side, it could be in front. Generally, they're directly in front of the fire hydrant in the middle of the street. But it's most important for the local building codes and fire codes to coincide with each other when it comes down to how many hydrants are needed in a specific area and how far are they going to be apart from each other. So the big thing when we put fire hydrants in, we got to understand what they are. Sometimes we have to put a dry barrel hydrant in because of the freezing that goes on. A wet barrel fire hydrant will be used in an area where there's no freezing of temperature. Dry barrels generally in the Midwest and the Northeast, where we have frigid temperatures all the time, and also in the upper Midwest as well. The big thing is that we want this hydrant to be able to be operational at all times, and the components are pretty simple. You have an operating stem, you have a bladder that holds it in place, and you got a stem nut at the top that basically is turned a certain specific way to open and close the valve itself. So the big thing is when you look at all this, you see how important it is. It's important for us to mark the hydrants appropriately. We're supposed to also need to put some flags out there when we're dealing with this in frigid temperatures and snow, so we know where the hydrants are at. It's important that we inspect the hydrants. It's important that we flow the hydrants, and more than anything else, we keep the hydrants clean and we keep them painted and lubricated at all times. If you don't do that, when you go to need that hydrant, it won't be operational. Overview of water-based systems is adequacy, the flow, and the duration that you're going to need. So the big thing is where does it go? Well, water flow is ensured that water temperature is at all times, or water supply at all times, of flow, pressure, and duration. How we commonly do know this is by flowing the hydrant. We do some testing by using a pitot gauge and that to find out what the flow is. And we also need to understand what residual pressure is in the hydrant as well, or in the water system that can be used in a major fire event. Back at this, we're looking at static pressure. What is static? That's when you just basically turn the hydrant on, put a gauge on the end, and see what the pressure is on the fire hydrant. Residual pressure is when you flow the hydrant and you see how much water is left in the main, and then you do a flow rate on the hydrant by calculation and flowing the water out of the hydrant. And the big thing is you'll see in a lot of communities, you'll see this above ground large tank. It's a gravity pressure tank, and it fills up with water, and basically it goes down into the distribution system and supplies it to the residential community or for our commercial district, whatever. It basically helps feed the community. Stationary fire pumps, you'll find those in buildings that need booster pumps in them. They're stationary like that. This pump is about the same type of pump you have in a fire truck, and you got to understand that this pump is going to thirst for water, and the fact that it's there because one thing is supplying the sprinkler system of the property, and more than anything, it has to have the right amount of water to feed it. So it's calculated once again by a fire protection engineer, and see how much water is coming off the fire main, so that it can feed the fire pump to feed the sprinkler system. You'll see this in high-rise buildings. You'll see this in basically any large structure that doesn't have enough water pressure to basically feed their sprinkler system. Of course, these systems are complicated. They have fire pump components. They've got drivers, controllers, a transfer switch, a jockey pump to keep pressure up so that the pump itself doesn't activate every 5 minutes. So that keeps pressure on the system. And there's control valves as well. One of the big things is we have to look at the fire protection pump assembly, system relief valves, bypass, test headers, gauges, eccentric and concentric reducers and increasers. It all is part of its system design in a sprinkler system supplying a building. Water supply designs for considerations or for the pump operation when there's just not enough water to pressurize the system. And then the pump inspection is tested annually, and quite frankly, there has to be an acceptance test, and the fire department is involved in that. So as we bring this chapter to a close, it's pretty basic. And the reason why it's basic is because it's about water, and water being distributed accordingly. So you got to look at these things, and you got to put them in context. Go out in your department when you're doing ride time or whatever you may do, if you're on shift, and see where the water really comes into the buildings and how much will flow. Look at what the gauge says as far as what their intake pressure is. Also, too, hook a fire hydrant up to the fire truck and see what the pressure that you'll get off the hydrant itself. Is there going to be enough water to flow 3,000 gallons a minute? Maybe not. So these are all key elements in the water distribution system. But the biggest thing you look at is you're looking at communities' domestic, commercial, industrial, and fire protection needs. The big thing is you want to look at more than anything else. Are the systems privately owned? Do they have a big well system and that drawing off of to supply their system? Or is it privately owned water system that supplies water to a community? And basically, like in some ports in Ohio, we have the Western Water System, and that they're privately held. They're like memberships, and people paid water and membership fees to belong to the water system. If it's a public system, it's pretty much open to everybody and you pay your monthly service fee. So you got to look at the valves. You got to look at the indication that's going on with the hydrant itself, how much water is coming in. You got to look at the hydrants and how firefighters are ready to use manual firefighting apparatuses, meaning fire pumpers and that. And do they have enough water to put the fire out? Take the next big fire that you're on and calculate how much water you use during that fire. You might be surprised how much you have and how much you don't have. So the two most prominent things in any of this is the hydrant itself. Is it a dry barrel or is it a wet barrel? The other part of this is the flow test. Are they being done by fire protection engineers? They give the calculations and then you accept it, and guess what? Then it has to be maintained at that accepted level at all times. So again, the chapter is kind of brief, but at the same time, it's got a lot of good information in it. Again, if you have any questions, let me know. Thank you.